So far in this course and throughout your math career, you felt, a little bit with square roots. And as we've seen, we have encountered numerous cases where square roots aren't evaluated into a perfect integer. For example, we know that the square root of 9 equals 3, but the square root of 8 doesn't evaluate into a perfect number. So when this happens, when we have square roots that don't evaluate into a perfect integer, we can simplify them by creating a factor tree. So you can think of this simplification. It's very similar to the idea of simplifying fractions, right? Because fractions, most of the time, don't simplify to a perfect number. For example, 3/2 is 1.5, which that's a decimal. Or here, a better example would be like 12/8, 12 over 8, right? 12 over 8, that doesn't evaluate to a perfect number because 8 isn't divisible by 12. Or 12 isn't divisible by 8, my apologies. So we can simplify this fraction. So the same idea applies with square roots. So today, or in this video, we're going to learn how to simplify square roots, just as we've learned in the past how to simplify fractions. Alrighty. So for example 1, we're asked to simplify the following integer square roots by using the factor tree method. So at essence, what we're going to do is we're going to create like a tree of factors to see what we can pull out of the square root. So looking at the square root of 8, because it's even, I'm going to automatically divide the square root of 8 by 2. So whenever you're creating these factor trees, if you're rather new to this factor tree method, whatever you divide the number by, that goes to the left. And then whatever you get as your answer, that goes to the right. So 8 divided by 2 is 4. And now I have to think to myself, okay, what can I divide 4 by? Can I divide 4 by anything? I can. I can divide 4 by 2. And 2 divided by 4 is 2. And now, looking at 2, I had to ask myself, can I divide 2 by anything besides itself? So the question you have to ask yourself, is this number here prime? So if you're unfamiliar with what a prime number is, a prime number is a number that you can only divide that number by itself and 1. So for example, 7 is a prime number, right? Because we can only divide 7 by itself. 7 divided by 7. Or you can only divide 7 by 1. You can't divide 7 by anything else. So 7 is a prime number because you can only divide 7 by itself or by 1. So that's this idea of prime numbers. So 2 is a prime number as well because you can only divide 2 by itself. You can only divide 2. So now that we know that 2 is a prime number here, and that once we get a prime number in our factor tree, we are done making our factor tree. So now that we know that, we're going to go ahead and look for groups of 2. Or we're going to look for any numbers that have 2 of them. So here, for example, we have a group of 2's here. So whenever you find groups of numbers in your factor tree, you're going to bring it around here, and you're going to bring that out in front. So we're going to have a 2 out in front, and whatever is left over, which there's a 2 here, you're going to put that under the square root. So you're going to get 2 times the square root of 2. And that's your final answer. Now, some of you might be asking, why did we ignore this 4 here? Why didn't we just bring that 4 up in the square root as well? That's a good question. And if you're wondering that, I encourage you to think about it this way, right? So this 4 here, we simplified this 4 by dividing it into 2 extra pairs. So this 4 here is going inside the square root or is being simplified, right? Because what we did is we divided 4 by 2 its factors. So this 2 and 2 is 4. It's just it's simplified more into more factors, right? So whenever you divide numbers, or whenever you like divide a number by more of its factors, the factors itself simplifies to it. So 2 times 2 is 4, right? So we already, in essence, put this 4 here. So that's one thing I want you to just be careful of and cognizant about, is that the numbers to the left of the factor tree and whatever's on the bottom is what's going to be in your final answer when you simplify a square root. So looking at example 2, we have the square root of 18. So I'm going to start by creating a factor tree. And because this is an even number, I'm going to divide by 2. So 2 divided by 18 is 9. And then I can also divide 9 by 3. And 9 divided by 3 is 3. And 3 is a prime number, right? Because I can only divide 3 by 1 in itself. So we're done here. And now I have to look for any groups of 2. And I have a group of 3 here. So I'm going to bring that out in front. So we're going to get 3 times the square root of whatever is left over. And on the left here, we have a 2 on the side. So I'm going to bring that 2 under the square root. And that's your final answer. Looking at example 3, we have the square root of 30. So because it's even, I'm going to start by dividing by 2. And 2 divided by 30 is 15. And 15, I can also divide that by 5 and 3. 3 is a prime number, so I'm done here. But the one thing is you might be looking at this and saying, well, there is no group of 2 here, right? We don't have any numbers that are the same. So what this means is that the square root of 30 is already fully simplified. We can't pull anything out of that square root. So the square root of 30 simplified is just itself, because the square root of 30 is already something simplified. So you can think of it as like square root of 30 is like if you want to think about fractions, for example, 3/2, if you were asked to simplify that, you'd be like, well, that's already simplified. The same thing for square root of 30. All right, so looking at example 4, we have the square root of 6. I encourage you to pause the video and try this one on your own. And assuming you've given it a go, let's go through this. So the square root of 6, because it's even, I'm going to divide it by 2. 2 divided by 6 is 3. 3 is a prime number, so we're done making the factor tree. And because there's no group of 2 here, we just have a 2 and a 3. Well, the square root of 6 is already simplified. And that's it. I didn't mean for there to be 2 simplified square roots in a row, actually. I only meant for there to be 1, but here we are. So for example 5, we have the square root of 63. So 63 isn't an even number, so I can't just start by dividing by 2, but it's an odd number. So automatically I'm going to think to myself, can I divide 63 by 3? And it just so happens that 63 is divisible by 3. So 63 divided by 3 is 21. 21 is also divisible by 3. So 21 divided by 3 is 7. And now I have to ask myself, is 7 a prime number? Or in other words, can I divide 7 by another number besides itself? I can't. So we're done with the factor tree. So looking for groups, I found here a group of 3. So I'm going to go ahead and write that on front. And then because the 7 is on its own, I'm just going to put that under the square root. And that's our final answer. Looking at example number 6, I encourage you to pause the video and try this one on your own. And assuming you have given it a go, let's go through this. So we have 2 times the square root of 72. So, because it's even, I could start off by, I'm going to start off by dividing by 2 because it's even. So 2 divided by 72 is 36. 36 is even, so I'm going to divide by 2 again. 36 divided by 2 is 18. I can divide 18 by 2 again, so we get 9 over here, because 18 divided by 2 is a 9. And then I know 9, well, that can be divided by 3, and 9 divided by 3 is 3. So, and over here, 3 is a prime number, so we're done. Now let's find any groups of 2 we can find. I found a group of 2 here, and a group of 2 numbers here. So we have a group of 2 and a group of 3. So what that means, so I'm going to carry along this 2 that's already out in front here in the square root. So I'm going to carry that along. So we're going to get 2 times this group of 2 here times that 3. And now I have to look, are there any numbers that are on their own in this factor tree, either to the left or on the bottom? Well, we have a number here, 2, which is all on its own. So I'm going to write that here. And now all we have to do is simplify. So 2 times 2 is 4. And then 4 times 3 is 12. So we're going to get 12 root 2 as your final answer. Alrighty, so now that we've worked with integers, we are now going to learn how to simplify square roots with variables. So simplify the following square roots using the factor tree method. So for example, 7, we have z squared. Now we're asked to use the factor tree method, but just looking at the example number 7, some of us might just know right away by looking at it, because we know the opposite of something squared is the square root. So this squared here would just cancel out with this root, and we know that we're going to get z. But using this factor tree method, we can divide z squared by z, right? Because using our rules of exponents, z squared divided by z, that becomes z2 minus 1, which is just z. So z squared divided by z is just z. And because we can only divide z by itself and 1, we're done with this factor tree. And oh, we found a group of z's. So our final answer is z, just as we expected. Now looking at example 8, let's go ahead and make that factor tree. So I know I can divide y to the 6th power by y. And y to the 6th power divided by y, well, that just becomes y to the 6th minus 1, which that becomes y to the 5th power. And then I can divide again. Y to the 5th power divided by y becomes y to the 4th. And then divide by y, we get y cubed. Divide by y, we get y squared. And then we're going to divide by y again. Y squared divided by y becomes y. Because we can only divide y by itself in 1, we're done with this factor tree. So let's see what we get. Well, we get a group of y's here, a group of y's here, and then this I kind of ran out of room. But then we also get a factor of y's here at the bottom of the factor tree. So what we get is the first group of y's multiplied by that second group of y's multiplied by the third group of y. So what is y times y times y? Well, using our rules of exponents, we know that these y's essentially have an exponent of 1, because anything raised to the first power is just itself. And we know when we multiply numbers, that means we're adding our exponents, so we get y, 1 plus 1 plus 1. And that equals y cubed. Now, before I go on to the other examples, I want to create a note here. So notice when we created these factor trees, we found how many squares, in essence, we can pull out of that exponent. So for example, notice that the square root of y to the 6th power equals y cubed. The square root of z squared equals z. So when we pull out how many squares that we can find from the exponents, notice in essence, we're just dividing these exponents by 2. So 2 divided by 2 is just z. 6 divided by 2 is just 3. So notice that we're in essence dividing these exponents by 2 and pulling out. When we divide by 2, we're essentially pulling out how many squares we can out of the exponent. But now looking at example 9, you might be like, oh, well now we have w to the 9th power, which that's an odd number, and 9 isn't divisible by 2. So what are we going to do? Well, here's a trick. I know, according to the rules of exponents, if we have x to the a times x to the b, right, we add our exponents. What if I were to tell you we can manipulate w to the 9th power to get it into something we like? So, or to get it in a form that we like, that makes simplifying the square root easy, right? So we can simplify, or we can rewrite w to the 9th as w to the 8th times w, right? Because w, in essence, has a power of 1, right? And 8 plus 1, using our exponent rules, is 9. So we can rewrite w to the 9th as w to the 8th times w to the 1st power. And now that 8 is an even number, we're going to pull out as many squares as we can because it's an even exponent. So in essence, we're going to do, what is 8 divided by 2? 8 divided by 2 is 4. So we're going to get w to the 4th power on the outside. And then because w on its own is just w, and there's nothing else we can do to simplify that, we're going to have the square root of w. And that's it. Looking at example number 10, I encourage you to pause the video and try this on your own. And assuming you have given it a go, let's go through this. So, using the same rule that we did in example 9, I'm going to go ahead and pull apart the powers of t to the 17th. So I'm going to do, say, t to the 16th times t, right? Because 16 plus 1 is 17, what we started with. And now I'm going to ask myself, okay, now that 16 is an even power, what is 16 divided by 2? Well, that's 8. So we're going to get t to the 8th power times the square root of t. Alrighty. Looking at example 10, or example 11, we have the square root of 10 times n to the 5th power. Well, now that we have numbers involved, some of us might be like, uh-oh. But the thing is, it's still just like what we've been doing before. So what we're going to do is we're going to treat this 10 as like a separate square root that we have to simplify. And then we're going to treat n to the 5th as another separate square root as we have to simplify. So we're going to have 10 times, so n to the 5th, right, as we've seen before, when we have odd powers, we can pull apart those powers to make our lives easier. So we're going to say 10 times n to the 4th times n, right? Because 4 plus 1 is 5. And we still have that 10 out here being multiplied by n to the 5th. So we're good. So now let's simplify this. So for 10, because it's an even number, I'm going to create a factor tree and divide by 2. Well, 5 is a prime number because I can only divide it by 5 in itself. So we're already done with that factor tree. So 10 can't be simplified. Looking at n to the 4th power, well, because it's an even number, I can pull apart 2 squares from it. So we're going to get n squared out in front. And then n squared is going to be multiplied by the square root of 10, because I can't simplify that anymore. And then we're going to carry along that n. And that's your final answer. All right, so for our final example of this section, we have the square root of 32 times a to the 26th power. So I'm just going to go ahead and rewrite the square root a little bit larger so we have more room to create factor trees. So we have 32, and then we have times a to the 26th power. So since our power is even, I'm just going to leave it as is. I'm not going to separate any of our powers, so we're going to have times a to the 26th power. All right, so now that we have that, all I have to do is create a factor tree for 32 and see what we find. So I'm going to divide 32 by 2. And 32 divided by 2 happens to be 16. Now, one thing I do want to point out here is notice that 16, if we were to put that under square root, the square root of 16 evaluates to 4, which is a perfect number, or in other words, 16 is a perfect square. So if you can recognize this, or if you recognize whenever you're creating factor trees that you have a perfect square, for example, 16, or another perfect square would be 9, right? So this idea of perfect squares is that it evaluates to a perfect number. So we know the square root of 9 equals 3, the square root of 25 equals 5, the square root of 4 equals 2, the square root of 1 equals 1. So if you recognize this, right, you can just stop here and say, okay, I know the square root of 16 is 4, so I'm going to pull a part of 4 here. Now, if you don't recognize that, you don't feel quite comfortable, yeah, that's completely okay. You can go ahead and continue and making the factor tree. So I can say, well, 16 is an even number, so I'm going to divide that by 2. We get 8. 8 divided by 2 is 4, and the 4 divided by 2 is 2. So now, finding what groups of 2 we have a group here and a group here. So what we get is 2 times 2, and then this 2 is all by itself. So that's going to go under the square root. And then a to the 26th power, since it's even, we can divide it by 2. So 26 divided by 2 is 13. So we're going to get a to the 13th power. And now to simplify this, 2 times 2, that's 4 times a to the 13th power times the square root of 2. And that's your final answer.